Welcome in this tutorial for midasNFX. We'll see how to simulate the 2D free surface analysis. So first of all, open the project. And in the new analysis setting, select 2D and choose the unit meter. It's always better to use meter, so please select meter in the unit. Click on OK. Now, please import the model. Okay, now I've got the model imported. I can hide the grid. So the first thing we'll do is to check in the options and go into General tab, Material CFD, and verify that the incompressible solver is used for the material. So this is very important for this analysis. Click on OK. Now let's define a material. Right click and create a new CFD fluid material. So you can choose the fresh water at 25 degrees Celsius from the database and click on OK. You can delete the alloy steel because we don't need it in this analysis. Let's create a 2D property for this CFD. Now let's create the mesh. So the first step will be to use a size control of the middle edges here on the model and input the mesh as 0.01. Okay, and we can go on with the meshing. So let's see the advanced option and choose triangle element, as I wish to mesh all in triangle, and for the size choose 0.1 meter. Can do the preview and click on OK to generate the mesh. Okay, now that we did that, we can define the boundary conditions. So the first of the boundary conditions that have to be defined is the function. So we'll define a few CFD function. So I go in the CFD tab, click on CFD boundary to create my first function. So the first function will be the velocity of the inlet. So I call it velocity x, and the value will be 0.2 plus 0.16 multiplied by sinus 0.5 t. Click on OK. Now you have it under the function velocity. Let's create another function. Okay, so this function will be used to define the level in the analysis, and will be defined like that. If y is higher than 0, then it will be 0, else it will be 1. Okay, now let's create another function which will be the pressure, and we'll define the pressure field during the analysis. So this function is minus 9.8 multiplied by dn multiplied by y. Now let's assign the other boundary condition. So first of all, define the inlet. So I will define all the boundary condition on the geometry. So I will temporarily inactivate the mesh, so I see only the geometry part. So select edge, so I select these 4 edges for the inlet, and for the velocity x, I just choose the function I created, and I click on OK. For the outlet, I'll choose a pressure, so I select these 4 edges, pressure will be 0. Now let's hide the mesh seeding, and I'll define some walls around the boat. So I click on wall, edge, I select the edges around the boat. The wall type will be no slip wall, and here I have to activate the motion control and create a new motion. So to define the motion, I will enter the weight of the boat, 50 kilogram, and here I have to enter the duration radius vector, so say 0.35. Let's activate the TY free rotation and the RZ free rotation, and assign this motion to the wall. Now I have to define the mesh deformation boundary condition and fix the mesh deformation on some areas. So here I will select these edges to fix the mesh here, and finally I'll define the free surface level, edge, same as the inlet, and use the user defined field, so it will be defined afterwards in the analysis case. Okay, the next step is to create the analysis case. So here we'll create a transient CFD case and click on edit to modify the settings. Go in the analysis control. The first thing will be click on advanced module and activate the mesh deformation and free surface. Then we can increase the number of steps to 1000. Let's decrease the number of maximum iteration to 1 to go faster. We can also put, let's say, 5 steps for the intermediate output request. And here we have to define the symmetric flow condition, which will be equal to -2 and 2, as I have 2 sides which are symmetrical, so I'm defining the edge on which the symmetric condition will be defined. Now click on field definition. Here in the pressure value, I define pressure function that I defined before. In the level, I have to define the level function, and I have to define the accurate turbulence value for the eddy kinetic energy and eddy length scale. So here it's 0.00088 and 1.684 power minus 5. Okay. Inner iteration, okay, there's nothing to change in here. I go in the module data, and here define turbulence model. So for the free surface, the best model is the Spalart-Almers, so I'll use this one. I have to activate the pressure reference location and activate the floatability by density. Be careful not to activate the second option, which is the hydrostatic term. So this one you should not activate it. And I will consider the mass conservation. Click on OK. I go in the output control. I verify that mesh deformation as well as wave elevation, temperature, okay, we need temperature, velocity, pressure, all that has been selected. I click on OK. I save my model and I can run the analysis. If I'm okay. As soon as the computation is over, I can click on total velocity and get the result. So I put the deformation to real and I have my analysis of free surface into dimension. So I can, for example, see the level set. So we see that the boat is going on the waves, and you have the creation of some small turbulence. This is a deformation of the mesh, which is calculated. Okay, and the pressure. And this is all for this tutorial. Thank you for watching.